This is very important question on line integrals. We need to evaluate this integral. First part, along straight line from z equal to 0 to 1 plus iota. And then along the real axis from z equal to 0 to 1. And then along line parallel to the imaginary axis from z equal to 1 plus iota. Then in the third part, we have to evaluate this integral along the imaginary axis and then along a line parallel to the real axis from the given points, right? Okay, let's start with the first part. Along the straight line from z equal to 0 to z equal to 1 plus iota. If you notice that we can write this 0 as 0 plus iota 0, which means we have this coordinate to be 0, 0, right? If this is your x-axis and y-axis, then this point lie over here, z equal to 0 lies over here, and then to z equal to 1 plus iota. The coordinate would be real part is 1, imaginary part is 1. So this is the point 1, 1. If I consider this to be 1 and this to be 1 and this 2 and 2. So this is the point z equal to 1 plus iota. Right? So this is your straight line y equal to x. Very fine. Alright. What is the given integral? It is the integrand is x minus y plus iota x square dz from 0 to 1 plus iota, right? So this is further equal to the integration of this integrand. We can write dz to be dx plus iota dy because your z is x plus iota y. So dz becomes dx plus iota dy, right? Because for the first part we have y equal to x. So we can replace either x with y or y with x, whatever way you like. And I'm going to replace y with x. So here it is, okay. So x minus x plus iota x square, and this is dx plus iota dx, and these two cancelled out. And now the limits is for x only. What are the limits for x? Here I'm having the point 0, 0. Here I am having the point 1, 1. So the limits of x are from 0 to 1. Is it okay? Fine. So further this is equal to the integration from 0 to 1. This is iota x square. And if I take dx common, I get here 1 plus iota dx. We can take this 1 plus iota outside of this integral, right? So this is equal to 1 plus iota. We can also take iota outside, and this is the integration for x square only. So this is iota 1 plus iota, and integrating x square with respect to x, we get x cubed divided by 3 with limits 0 to 1. So if I multiply iota inside, I get iota plus iota square, that is minus 1. And putting the upper limit for x, we get 1 by 3. Minus putting the lower limit, we get 0. So this is iota minus 1 divided by 3. Or we can also write this as minus 1 by 3 plus iota divided by 3. Right? So this is the required answer for the first part. And in the next part, we need to find the integral along the real axis from z equal to 0 to z equal to 1. First, let's find the integral along the real axis from z equal to 0 to z equal to 1. That is the point 0, 0, and this is 1, this is 1. Z equal to 1 means, because it is your real axis, so here the imaginary part is 0, right? So it is the point this. So we need to find the integral along this line first, and then along a line parallel to the imaginary axis from z equal to 1 to z equal to 1 plus iota. the line parallel to the, this is your imaginary axis, right? The line parallel to the imaginary axis, that is from z equal to 1, from z equal to 1 to z equal to 1 plus iota. 1 plus iota means the point 1 1. So from this point to, okay, so let me name this as the point O, and this is the point A, and this is the point B. So first we are going to evaluate the integral from the point 0 to A first, right? Okay. So we need to evaluate the integral first from 0 to A and then from A to B. Complete path is OAB, right? So along the path OAP, that is the integration is from 0 to 1 plus iota, right? Or the point 1 1. So 0 to 1 plus iota, and the integrand is x minus y plus iota x square dz, which is further equal to, that is, it is further equal to, we are going to split this path from O to A and then from A to B. So along path OA and then along the path AB. So we need to evaluate these two integral and then sum up these, right? Okay, first let's evaluate along the path OA. The integration along the path OA with integrand x minus y plus iota x square. Okay, we know that dz is dx plus iota dy, and along the real axis y disappears, right? So dz will be dx only, and the limits are from 0 to 1. We need to write the limits for x. We need to write the limits for x, that is from 0 to 1. And now integrating this, this is x squared divided by 2 minus y. Okay, what is y? So the integration from 0 to 1, x, y disappears, it vanishes, plus iota x square dx. So integrating x, we get x squared divided by 2 plus integrating x squared, it is x cubed divided by 3 with the limits from 0 to 1. When putting the upper limit, we get 1 divided by 2 plus iota 1 divided by 3, right? Minus, when putting the lower limit, we are getting this to be 0, that is, we are getting the final answer to be 1 divided by 2 plus iota 1 divided by 3. And now we have to find this integral along AB. Now along AB we have the constant value of x to be 1, because this is your path, AB path, and the constant value of x is 1, right? So for this you have to take x equal to 1, so dx becomes 0, and this integral is now, the integrand becomes, here you have to write x1 minus y plus iota dz becomes dx plus iota dy. So dx is 0, we write iota dy, and now we have to put the limits for y. The limits of y are from 0 to 1. Is it okay? Fine. All right. So now integrating. Okay, before integration I am taking this iota outside of this integral. So let me write this outside of the integral. Okay, and now I am going to integrate this. This is y minus y square divided by 2 plus iota y with limits 0 to 1. When putting the upper limit, we get 1 minus 1 half plus iota. When putting the lower limit, we get 0, right? So this is 1 minus 1 half is 1 half, and we are getting the answer to be, okay, iota multiplied with iota, that is iota square, that is minus 1, the real part is minus 1, plus imaginary part is 1 half. So now we are going to put these two values back to the main integral here, right? So now adding the values for both these integrals, the value of first integral is 1 half plus iota 1 by 3. plus the value of the second integral is minus 1 plus 1/2, that is iota 1/2, and 1/2 minus 1, that is minus 1/2, and 1 by 3 plus 1 by 2, that is 5 divided by 6. So this is iota 5 divided by 6 is the required answer for the second part. And similarly we have to solve the third part also. That is, we have to evaluate the integral along the imaginary axis from z equal to 0 to z equal to iota. Z equal to 0 means 0, 0 point, to z equal to iota, because it is along the imaginary axis. So here the real part is 0, so this is 0, 1. Iota can be written as 0 plus iota, right? So real part is 0, imaginary part is 1. So this is the point 0, 0, this is x-axis, this is y-axis, and 0, 1, that is from this point to this point. It is the point 0, 1. So we have to find the integral along this line first, along the imaginary axis first, and then along a line parallel to the real axis from z equal to iota to z equal to 1 plus iota. This line is parallel to the real axis from z equal to iota. That is from this point. This is your point z equal to iota, right? To z equal to 1 plus iota. 1 plus iota is, the coordinate becomes 1, 1. So this is this point, so along this line. So let me name the points. Let this be O, this be A, and this be the point B. So the path is OAB. Finding the integral for the path OAB, that is, this is z equal to 0 and this is z equal to 1 plus iota. So from the limits will be from 0 to 1 plus iota for this path, 0 to 1 plus iota. For the path OAB, right? The path is here OAB. And the integrand is x minus y plus iota x square, and here dz. We have to split this path into two. That is, first we have to evaluate the integral along the path OA. And then we have to evaluate this along the path AB. Right? Okay. So let me solve first this integral. I'm not writing the integrand. It's okay. The integrand is this only. Okay. Along the path OA. So the integration is along the path OA. Integrand is x minus y plus iota x square and dz. Along the path OA, x vanishes. So this is x is 0. So we have minus y plus iota. This is 0. So we have only here minus y. And dz will be, because it is dx plus iota dy. X is 0. Dx will be 0. So this is iota dy. And we have to write the limits for y. What are the limits? It is from 0 to 1. So minus iota, now integrating this, we have y square divided by 2, limits from 0 to 1. So this is minus iota, putting the upper limit, 1/2 minus then 0. So we are getting minus iota by 2. And now solving the integral along AB. Along AB, we have the constant value of y to be 1. We have the constant value of y, that is 1. Everywhere y is equal to 1. So for this path, we have to consider y to be equal to 1 and dy will be equal to 0, right? So this is equal to the integration x minus 1 plus iota x square, and dz will be dx plus iota dy. So we have to write dx only, dy is 0, and the limits for x we have to write. What are the limits for x? It is from 0 to 1. Now integrating this, it is x squared divided by 2 minus x plus iota x cubed divided by 3, limits from 0 to 1, minus 1 plus iota divided by 3. Putting the lower limit, we are getting everything to be 0. So this is equal to 1 half minus 1, that is minus 1 half, and the imaginary part, that is iota by 3. So this is the required answer for the path AB, and now we are going to add these two answers of the integrals. First is minus iota by 2 and second is this one. The value of the first integral is, for this integral we have the value to be minus iota by 2, plus the value for the second integral is minus 1 half plus iota by 3. So this is equal to, I am writing the real part first. Okay, minus iota 1 by 2 minus 1 by 3, minus 1 by 2 minus iota, this is 1 divided by 6. So this is minus 1 half minus iota by 6 is the required answer for the third part. So this is how we evaluate the line integrals along the given paths. So in the next content again we are going to solve some more problems on this. Okay, thank you. Have a nice day.